What if something as simple as wearing a cast could lead to a wound so severe it ends in amputation, without the patient ever feeling a thing? Diabetic pressure ulcers often go unnoticed and untreated in casted patients with diabetic neuropathy because of a dangerous combination of reduced sensation, poor visibility under the cast, and limited awareness of how fast these ulcers can escalate. These ulcers are incredibly difficult to treat, with stage 4 wounds often taking over a year to heal and about 1/3 never fully recovering. Pressure ulcers in this population form silently and quickly, progressing from minor injuries to deep wounds or even amputations. Current casting protocols don't account for these risks, and there's no standard way to monitor pressure inside a cast. Introducing SmartS, a cast-compatible sock system that doesn't just monitor pressure but actively prevents pressure ulcers before they begin. Firstly, let's look at the current protocol. When a patient receives a cast, clinicians place a stockinette and pad bony areas with felt or cotton. Then undercast padding is applied and the limb is casted in bandages. For diabetic patients with neuropathy, pressure points go unnoticed due to lost sensation, leading to the silent formation of stage 1 pressure ulcers, which can worsen to stage 4 or 5. Treating them often requires bivalving or windowing the cast, compromising its structure, delaying fracture healing, and increasing medical bills. Now this is where SmartS comes in, a two-part pressure detecting and relief system. First, the patient wears the SmartS stockinette, a sock embedded with thin pressure sensors at the heel and ankle. It continuously monitors pressure levels and transmits data via Bluetooth to a phone application. The battery and Bluetooth unit can be rotated as needed for comfort. Next, the SmartS bubble patch is worn. It is a TPU layer filled with pressurized air pockets placed directly over target areas. It redistributes stress under the cast without compromising its structure. Then the cast is applied per normal. If the patient's heel remains in the same position for a prolonged time, the phone application detects this based on personalized thresholds and sends an alert to the caregiver. It also gives personalized instructions like elevating the foot. Instructions can be edited based on the patient's history. This prevents pressure injuries from going unnoticed and saves the patient both time and money. Together, these two components work passively and actively to prevent pressure ulcers. This is the proof of concept that we did using LabVIEW software and the DAQ. When threshold was exceeded for more than 2 hours, the LED light turns on, and after the pressure was removed for 2 hours, the LED light turns off. This is the CAD model for our pressure offloading layer in the form of a bubble patch. The compression test shows that the gel padding is able to withstand till 135 kilograms. This shows pressure distribution capability, where it's evident that the gel padding effectively disperses majority of the pressure applied. As part of our future expansions, we plan to improve on our bubble patch using an alternating pressure technology. This will have 3 modes as shown here. SmartS uniquely combines pressure detection using sensors and offloading with a bubble patch in a thin, cast-compatible sock at just SGD $75 per unit. Its modular design uses low-cost materials like washable bamboo and flexible sensors, and it works without cloud systems or software training, making it simple to deploy in community clinics, rural hospitals, and even home care. Unlike existing devices built for walking patients, SmartS is tailored for immobilized users and integrates directly into current casting workflows without disruption. Alerts are sent only when pressure persists for over 2 hours, helping caregivers act early without digital overload. SmartS doesn't just monitor pressure, it detects and prevents ulcers before they start.